All right, we're talking about indirect measurement, and these really are going to be your real-world situations for these similar triangles and why we need to know this information. So just as a reminder, remember that in order to do these similar triangles, we really just set these up as proportions, because in order to be similar, the sides have to be proportional, and we're just solving for x, doing that cross multiplication and solving. So in this example, you see you have one triangle here, and then the other triangle is this whole thing, right? Okay, so we're just going to set up a proportion, and we can do big to small, we can do small to big, just as long as you know which one you're always putting the same one on top and the same one on the bottom. All right, so if we say x is to 5 as 22 is to the 10, right? So the big one's on the top, the bottom length of the small one on the bottom. Okay, so we're just going to cross multiply. So 10x is equal to 22 times 5, which is 110. Divide both sides by 10, so x is 11. Okay, so it's just easy as that, as long as you can figure out your different triangles. So here we have 6 is to 3 as x is to 8. So 3x is equal to 6 times 8 is 48. Divide both sides by 3, so x is 16. All right, so here's some of our real world examples. Okay, so let's just say you're a window washer. You need to know how many square feet or square meters of windows that you're going to wash. Maybe that's how you charge. So you need to know the height of this building that's covered with glass windows. I don't know, something like that. So this is a good way to do it. You've got a tree here, and so the tree maybe is casting a shadow of 24 meters. Though you see that the building is casting a shadow of 56 meters. Well, then you can just set up a proportion for that. Okay, so we'll say the height of the tree over the shadow. Okay, so the height of the tree is 21. The height the shadow of the tree is 24. The height of the building we don't know, but the shadow of the building is 56. And we just cross multiply. So 24x is equal to 21 times 56, which is 1,176. Divide both sides by 24. So the height of that building is 49 meters. This really is helpful. One time my brother was cutting down a tree, a big pine tree, and he didn't want it to hit his fence or his house. He knew exactly about where he was going to be able to drop it, because he's pretty good at that. And he asked me if I could help him figure out how tall the tree was to see if it was going to hit his fence or not. And we did that, and we did the same kind of thing, set up a shadow with someone who was about 6 foot tall in the shadow of the tree. We figured out he had about 4 feet to spare. I called him in about 2 weeks, and I said, how'd that tree come down? He goes, I had about 4 feet to spare. So we did pretty good on that. So that's a real world example of using these similar triangles. Okay, so here's another example. When Stephanie stands 2 feet from a lamppost, and I always like to draw pictures. So here's my little lamppost. Okay, and I'm a bad picture drawer, so it's okay. Her shadow, she's 2 feet from it. So let's put 2 feet here. Here's Stephanie. She has a shadow of 3 feet. Okay, if Stephanie is 5 feet tall, how tall is the lamppost? Okay, so I probably should have drawn my lamppost a little bit taller, but see, this is 5 total. So she is 5 feet tall and casts a shadow of 3. The lamppost, we don't know how tall it is, but it's casting a shadow of 5. So we've got 3x is equal to 25 Divide both sides by 3. So x is 8.3 feet tall. Okay, so another example. Each time Old Faithful in Yellowstone National Park erupts, rangers can estimate the height of the geyser by comparing it to the height of a tree. First, the rangers locate a tree at the same height. The shadow of the tree is 93 feet. So let's put shadow, because now we're going to deal with that, is 93. At the same time, the shadow of the ranger is 6 foot. Oh, a 6-foot ranger. So shadow over height. So see how important that is to set that up right. Okay, so his shadow is 4 feet. He is 6 foot tall. We're trying to find the height of the tree. Cross multiply. 93 times 6. 558. Divide both sides by 4. X is 139.5 or 5/10 of a foot. So there's the height of that tree. And that's sort of exactly what I did. Okay, so we have another example here. Just I often will at least start off writing this over here so that I don't get them mixed up of how I'm setting it up. So sometimes that's very helpful for you so you don't get your numbers mixed up, because if you get the numbers mixed up on one, then that does give you the wrong answer. So, okay, a mirror is on the ground. So here's my little mirror. I don't know. 8 feet from Ricky. So there's 8 feet from the mirror to Ricky. Ricky can see the top, and 19 feet from a flagpole. Okay, so the mirror is 19 feet from a flagpole. So we've got a pole here, waving our flag, right? Okay. Ricky is 6 foot tall. How tall is the flagpole? Okay, so we're going to do height and distance from the mirror, right? That's how we're going to set it up. So the person is 6 foot and he's 8 feet from the mirror. The flagpole, we don't know how high it is, but it's 19 feet from the mirror. Okay, so cross multiply. 8x is equal to 6 times 19, which is 114. Divide both sides by 8. X is 14.25 is how tall the flagpole is. And that is all in feet. We should be writing those. Okay.